So now the problem is given on isometric projection of hexagonal prism of sides of base 30 mm and axis length 60 mm. Okay, and a right circular cone of base 40 mm has diameter and altitude 50 mm resting on its top such that the axes of both solids are collinear. So it is a combination of two solids, that is hexagonal prism at the bottom and top a cone has to be placed. Okay, construction of hexagonal prism. As per the previous problem, we learnt about that. It is 30 mm base hexagon. How to construct that? I have shown it here. So now a cone has to be placed in both this hexagonal prism. So cone base diameter is given as 40 mm. So construct that 40 40 mm base diameter means construct from here the top center. So this is the top center, bottom center to top. So take half of the given diameter, 20. Okay, and take 40 mm. Angle is 30. 40. So now from this point, take opposite lines, this line's midpoint, construct a line. And from here to take compass and construct, take this as the center and this as the radius. Next take this as the center, this as the radius. Now from this center, what is the height given for that? Cone is 50 mm. Okay, so take 50 mm and join tangents. Okay, so now as per the condition, the two axis means two axes. Okay, this axis and this axis are collinear. Okay, the two solids axes are collinear. So as per the condition, we have constructed the base is hexagonal prism and top is cone. So now remove all the unwanted things. And convert to ISO scale. Okay, this is a combination of two solids. So now in this problem they have given a cone of base diameter 50 mm and height 40 mm placed centrally on a square slab of sides 80 mm and height 20 mm. Draw its isometric projection. It is a combination of two solids, that is cone and square slab. So which is placed on which? A cone is placed centrally on square slab. So bottom portion is square slab and then top portion is cone. So first construct square slab 80 mm all the sides, 80, 30, so you can easily construct like this, 20 mm thickness. And 30. Now find center. So we need to construct cone of base diameter 50 mm. So from the center take half of that, 25 mm. So start from here. Okay, 50, 30, 50, 150. So now go to arc by center point. Convert to ISO scale. Delete all the unwanted. So this is one more problem. So in your solution book, 19th problem. So they have given orthographic projection in that solution book. So look in that book. That is, they have given front view and top view, and also they have given the problem in the form of sentence. That is, a pyramid of base 40 mm by 25 mm and height 50 mm is placed centrally on rectangular slab. Okay, sides 100 by 60 mm, thickness 20 mm. So draw the isometric projection of the combination. So this is a combination of two solids. So which are the two solids means? First is pyramid and next is rectangular slab. So now you need to check which is placed on which. So rectangular slab is at the bottom. On rectangular slab, pyramid has been placed. Okay, so how it is placed, you have to check that in solution book, problem number 19th. So you have to show the isometric projection of that two solids. So now first I'll construct the bottom rectangular slab. Thickness 20. So now find center here. And now the rectangular pyramid is of 40 by 25. So this side 40 mm and this portion will be 20 mm. So I will take 20 mm on either sides. And next 12.5 this side, and next 40 mm, and next 25 mm. So in grid sheet on the grid lines you have to place this, otherwise use any other parallel line in the grid sheet. The height is 50 mm. So now convert this to isoscale. So one more problem is there, that is a square prism of base sides 40 mm and height 50 mm placed centrally on a rectangular slab of sides 100 mm by 60 mm and thickness 20 mm. So draw the isometric projection of the given combination. So it is in the problem number 21 in your solution book. Okay. So in this problem there are two solids, combination of two solids. So what is that? The two solids are square prism and rectangular slab. Okay, which is placed on which? Rectangular slab is at the bottom. On rectangular slab a square prism is placed. First we'll construct the bottom portion. Rectangular slab of 100 by 60. So check this problem in a solution book. They have written isometric orthographic projection, front view and top view. So by seeing that you have to write isometric. So first 100 mm by 60. Thickness is 20 mm. Now find center. Now you have to construct square base prism. The base is square. Inside take from the center. So it is 40 mm base side. So I'll take 20 mm, half of that downwards, and I'll start from here. 40, 30, next 40, 150, 40, minus 150, and join this. Now from each corners the given height is how much? 50 mm. So construct 50 mm. So now convert this to isoscale. So this is the combination of two solid, that is a square base prism has been placed on rectangular slab. Okay, so only this thing is enough. Final thing you have to represent in your answer sheet. So these are all not needed. So there is one more problem, that is a sphere of diameter 60 mm is placed centrally on top face of square prism of 60 mm base sides and height 70 mm. Draw its isometric projection. So here there are two solids, a sphere and prism. So which is placed on which, means prism is on the bottom side and diameter, this one sphere is on the top side. Okay, so first construct square based prism. So this problem is in solution book, number is 33. So I construct first prism 60 mm base sides. So you can construct either to the upward, or you can construct, if you consider this as the bottom face, you have to construct all the vertical edges upside, and if you consider this as the top face, construct the bottom portion. Height is 70 mm. Now find center. Since we need to construct a sphere here, so now after constructing this, convert all the things to isoscale, and only sphere has to be constructed in actual scale. Okay, because when you tilt the sphere is in a round shape. When you tilt the sphere in any angles, okay, if you give any angle and you rotate that, it looks like the same diameter or the same shape. It doesn't change its shape if you tilt in any direction. If you rotate in any direction or if you give any angle, the sphere remains same in shape and as well as diameter. It doesn't change its shape and size. Okay, so while constructing sphere, it must be in actual dimension in isometric projection. Rest of the things must be converted to isoscale. So if you are constructing in grid sheet, isogrid sheet means construct all the things by using grid lines. Only sphere has to be constructed by actual, that is use 60 mm diameter, use compass, and from taking from here as a center point, construct 60 mm circle. Whereas if you are constructing on white sheet, plain sheet, means convert all the dimensions. Okay, if it is 60 mm means, sorry, 70 mm height means 70 into 0.816, it becomes 57.12. so convert all these things to isoscale. Okay, if you are constructing on white sheet. Okay, then after converting all these things, only sphere has to be constructed with actual dimension. It has to be constructed 60 mm by using compass. Don't reduce the sphere diameter as per the isoscale. Okay, so now I have converted everything to isoscale. Now I will construct the sphere with visible line. The actual diameter given is 60. Okay, so this is the construction procedure for sphere and combination of sphere with any other solid. Okay, so now I will trim out all the rest of the things. This is how it looks when a sphere is placed on a square prism. First construct prism, square prism, find center. From the center, okay, take the radius. If sphere is 60 mm means take 30 mm, it comes here, this point. From that point you need to construct sphere. So before constructing sphere, convert all these things to isoscale, then construct sphere.